All right, here's the pulleys problem. You've got two pulleys. They say they're 13 inches apart. I assume that's the centers are 13 inches apart. They tell me the small radius is 3 and the bigger one is 6. Um, and you want to find the length of the pulley, the belt that goes all the way around. Okay. Um, First of all, what I'm going to do is I'm going to just look at half of it. I'm going to just do the top half and then multiply by 2. Okay. Um, Now, a couple of things that make this work. One is that when the belt comes into the pulley, that right there is that point of tangency. That is a tangent line, and in fact, the tangent line is perpendicular to the radius. So this is 3. That's a right angle right here. Likewise, where it takes off from that, that's going to be perpendicular. Okay. I know that this is total of 6 radius here. I say total of 6 because what I want to do here in order to get this to work is to draw a line parallel to the belt there, up to there. If it's parallel, then this is a rectangle. I mean, that's a right angle, that's a right angle, you got a rectangle here. So this is a 3. This is also 3. The total was 6, so this is 3. They told me the distance apart between the two centers is 13. So I have got a lot of information here. In particular, look at this length right here. I'm going to call it x. This length from here to there, that's actually the length of the belt that you can see exposed. Right? But I've got a right triangle now because that's a right angle. And so x squared plus 3 squared is equal to 13 squared. And I've got that x is equal to the square root of 169 minus 9, which is the square root of 160, which I'll just leave like that. I mean, I could give it as a decimal, but I'm not going to round until I'm done. One of the problems with doing, one of the issues with doing problems like this is that people round too soon, and then they use their rounded answers, and you end up with answers that are way off. So leave it as best you can here in the exact form until you're done. So x is the square root of 160. So I've got the square root of 160 is that length. Now what I need to find is I need to find this arc length, and I need to find that arc length. Well, I can find that arc length if I knew this angle here. And I think I can get that angle because I think I can get that angle in there. Right? Because look at that triangle. That little angle, we're going to call that angle theta, just to have a name for it. I know that the sine of angle theta is 3 over 13. So theta is the inverse sine of 3 over 13. Now when I use my calculator to calculate that angle, I'm going to make sure I do it in radians, because I'm going to calculate an arc length here. Right? I'm going to use that to calculate this arc length. In particular, let's look at this angle right here. Let's call this angle alpha. Right? I notice that alpha and this right angle and that angle all add up to a straight angle, which in radians would be pi. So I know that alpha plus pi over 2 plus this thing that I just calculated, sine inverse of 3 over 13, is equal to pi, and so I can solve for this alpha. So alpha is equal to what? Well, the pi minus pi over 2 is pi over 2, and then subtract off that inverse sine of 3 over 13. And again, I'm not actually typing it into my calculator yet to give a decimal because I don't want to round quite yet. Because what was I going to do with that alpha? So knowing the angle, I can calculate the arc length, because the arc length is the angle times the radius. So let's call that arc length over here, let's say S1. So, and I choose S1 because I'm going to use S2 over there. So S1 is equal to the radius of 3 times this angle, whatever that is, pi over 2 minus the sine inverse of 3 over 13, right? So I'm going to type this in my calculator, get an angle, and then multiply by the radius. And actually, I don't know why I wrote an r there, because I know the radius of that circle is actually 3. Okay. Now I'm going to go back and say I need to find this arc length over here. Well, that means I need to know this angle right there. Well, do I know this angle? And I think I do know that angle because it's the complement of this one. So we're going to call that, oh, let's call this beta. No, let's call this pick a, no, beta's good. So actually, what I want here, because this is the one I'm really looking for, let's call this phi, right? Phi is going to be pi minus beta. So phi is pi minus beta, but beta is the complement of alpha, no, the complement of theta. Actually, though, I think what I'm going to do is I'm just going to say that beta is the angle whose cosine is 3 over 13. So beta here is the cosine inverse of 3 over 13. I'm going to zoom in on that again here. Right, that I have this triangle. Here's the angle. The cosine of beta is the adjacent side over the hypotenuse. So that's 3 divided by 13. So I've got that angle by using an inverse cosine. And I've got this. So now the arc length that I want over here, S2, is that angle times the radius of 6. So 6 times this, pi minus the cosine inverse of 3 over 13. Okay, so the total now is going to be the two arcs added together and that square root of 160, and then multiply the whole thing by 2. So they call it L is going to be 2 times the square root of 160 plus this thing, 3 times pi over 2 minus the sine inverse of 3 over 13 plus 6 times this stuff, pi minus the cosine inverse of 3 over 13. So now I get out my calculator and type it all in. One thing to point out here is that when I'm doing these sine inverses, I got to make sure my calculator is in radian mode. That in order to use angles to calculate arc length, everything has to be in radians. So my calculator is in radian mode. Yes, it is. I just checked. And then I'm going to type all this stuff in. I'm missing a set of parentheses here. So I'm going to type all this stuff in. And when I get all done with that calculation, I get 54.96976, whatever. So just under 55, I guess that's inches long. So 13, sure. So I'm just kind of double checking. So it's like 27 on going around this way, and there's already 13 there, so yeah, that's probably about right. Anyway, it certainly was not a trivial problem. The real key, I think, comes in drawing that line there, which gets you that right triangle down in there where you've got some information you can work with. So anyway, there you go.